Well, hello, chemist. This is Mr. Kirsten, and today is Friday. I hope you enjoyed the coffee house, and I'm going to do one of your homework problems for you here. So, we are going to do from homework number 28, problem 29. So, if you take out a piece of paper and a pencil and write down what I'm going to write down here, you can have one of your homework problems done. Not to mention, learn a little something about theoretical yields. So before we get going, I thought I'd just show you what I might be spending over while I'm in Japan. This is 10,000 yen. That's right, Mr. Gersen's rich. He's got 10,000 yen, right? Turns out this is about 10 bucks. So anyway, hopefully I won't need too many of those. All right, so problem 29 from homework 28 says the following. Zinc reacts with iodine in a synthesis reaction. Determine the theoretical yield if 1.91 moles of zinc is used. Determine the percent yield if 515.6 grams of product is recovered. Mr. Kirsten, I have no idea what you just said. What is going on here? Well, remember that every problem in this chapter is going to start with a balanced chemical equation. So I'm going to just go ahead and write that down so I can refer to that. Now, I really like this equation because all of my coefficients are 1, which makes things a little bit easier. Let's talk a little bit about theoretical yields, okay? What is a theoretical yield? A theoretical yield is the maximum amount of product that can be produced under ideal conditions, all right? So a theoretical yield is saying if everything was perfect, if there was no impure reactants, if there was no competing side reactions, if no product was lost when you cleaned your beaker, if everything was just perfect, this is the maximum amount of product you could get. Kind of like the perfect amount. So how do you find your theoretical yield? Well, you just do the stoichiometry that we've been doing so far. So I know I start with 1.91 moles of zinc. The mole ratio between zinc and zinc iodide is my favorite mole ratio, 1 to 1, right? So for every 1 mole of zinc I put in, I get 1 mole of zinc iodide out. So according to my calculation here, the maximum amount of zinc iodide I could get out of this reaction would be 1.912 moles. All right. Notice my moles of zinc cancel out here, and I get the product that I want. All right. Okay, so that would be the maximum amount. That would be the theoretical yield, which is what Part A was asking us for. But then in Part B, it says the following. If the actual yield is 515.6 grams of zinc iodide, what would the percent yield be? Well, okay, what is a percent yield? Well, as it turns out, the real world is not perfect. We do have competing side reactions, so there's not just always one chemical reaction that takes place at any given time. Sometimes there's 2 or 3 or 4. Sometimes you lose product when you filter it. Sometimes your reactants might be impure. Maybe I got a little zinc oxide in there. It's not all zinc. Things aren't always what you think they are. So a percent yield says, hey, if you did things perfectly, you'd get a perfect amount, a theoretical yield of 100 of everything you possibly could. But in the real world, that doesn't always happen. So a percent yield's kind of like a score. If you're supposed to get 100 grams of something, you get 80 grams. Well, you got 80% of what you should have. All right. So actual yield can only be measured in the laboratory, or you would have to be told what an actual yield is. A theoretical yield can be calculated from how much reactants you start with, but an actual yield, you have to actually carry out the experiment and measure it, or you would have to be told, hey, this is how much was produced in the actual yield. Okay, well, let's calculate this percent yield so we can be done and practice some homework problems on our own. Well, for percent yield, notice here that I should really have the same units. And right now I have a theoretical yield in moles and an actual yield in grams. So it wouldn't really make sense to divide these right now. You got to be comparing apples to apples when you do a percent yield. So let's just do a quick calculation here. And why don't we change our theoretical yield in moles into grams. And we're going to do that just using the molar mass of zinc iodide, right? So how did I get this number 319.19? Well, that's just the molar mass, right? So I did 1 times 65.39 plus 2.2 times 126.9, right? And I got my molar mass of zinc iodide, right? Okay, so this is my new theoretical yield. It's in grams, which is the same unit as my actual yield. So now I can plug in my numbers here and get my percent yield. So I'm just going to squeeze this up a little bit, and it'll show you here your percent yield then is your actual yield, 515 grams, divided by the theoretical yield, 610 grams. That's 0.854. I multiply that by 100% and get 84.5%. So my percent yield here was 84.5%. So I hope that's a good example of how to calculate percent yield. And for being such good chemistry students, your reward is you're going to get a piece of Pez out of an R2D2 Pez dispenser. Are you ready? Are you ready? Oh, here you go. All right. Nice work, chemistry students. So the rest of the hour, you can be working on some other homework problems from homework 28. See Mr. Bird. He's got the answer book if you want to check your answers. Good work. Take care.